So today we're looking at this section 1.4, perimeter and area. We're going to be able to figure out the perimeter and area of figures in a coordinate plane. We do a lot, this is called coordinate geometry in this class. We will do a lot more second semester. And it basically is a lot of finding the lengths of things, okay? And so we want to do that here. We're going to use the distance formula, which I put on there for you, big giant square root formula. And we're going to see what we can do to plot the given points and then determine the perimeter and area of the figures indicated. And the directions might not be exactly the same on Delta Math. I think it might just be perimeter on Delta Math, which is fine, but I thought we could review a little bit of area too for some of these, so we're going to do that. We want to find the perimeter and area. What is perimeter? The outside, yeah, of the figure is all the sides. Add all the sides. I'm going to say side lengths. All right. So to find the perimeter of something, we have to add up all the side lengths. And then hopefully you know a couple formulas of area, like the area of a rectangle. Do you know the formula for the area of a rectangle? Area of a rectangle? Length times width, yeah, length times width would be the area of a rectangle. Sure, length times width, very good. All right. Okay, so let's plot these points. The nice thing about Delta Math is it won't let you plot them incorrectly. All right, so 8, 1, I got to move horizontally, 8, and then we can go up 1. So there is point F, and whenever you plot something, you want to label it so we know what we're looking at there. And I think I'm going to go ahead and put the 8, 1 on there just so I can look at it later. All right, G is 2, so I need to move horizontally 2 and then up 1. So there is G at 2, 1. H is at negative 2, so I need to move left 2 and then down 8. So negative 2, negative 8 is point H. Negative 2, negative 8. And then I is at 4, negative 8. So I need to move right 4 and then down 8. Oh, my eyes are getting old. Boy, it really just hits like a wall. All of a sudden, you're like, whoa, what is going on? Okay. So on Delta Math, that'll ask you to plot the points, and then you push like graph or something like that. Try. And then it connects into this lovely figure for you. What figure is this? What shape is it? Parallelogram. Yeah, this is a parallelogram. You're right. Okay, and so today, to start, we're going to find the perimeter. And what that means is I need to find the lengths of all these sides. Well, the nice thing is it is definitely a parallelogram. And it turns out that the opposite sides are going to be the same length, which is pretty nice. So what I'm going to do is I'm going to look at the length of this side right here, which uses point F and point I. So I want to find the distance between point F and I. And so this is how I denote that. I want to use the distance to find the length of segment FI. Now, I'm going to set that up and use a big giant square root. And I got my bubble squared plus another bubble squared. And to do this formula, we want to subtract the x-coordinates. So my x-coordinates are 8 and 4, so I'm going to do 8 minus 4. And then I have to subtract my y-coordinates. So my y-coordinates are 1 and negative 8, so I'm going to do 1 minus a negative 8. All right, I'm going to do a little bit of cleanup here. 8 minus 4 is 4, okay. And so I have 4 squared. 4 squared is 16. 4 times 4 is 16. And here I have 1 minus a negative 8. What is 1 minus a negative 8? It's just a plus, yep. So that becomes 9. And then 9 squared is 81. So, and then if I add those up together, radical, what is it? Thank you. It's too early for math, you guys. All right, I'm going to put that into my calculator. And I think we probably, you know what, I'm going to leave it. I don't want to round it. Save your rounding until the very last step. Radical 97 is a beautiful answer, okay? We're going to leave it radical 97. So what I just figured out is this side is radical 97. What is this opposite side going to be? Radical 97, okay? So I'm going to save that. I'm going to leave it as an exact answer. And this is something you're going to learn throughout this class, and in the future math classes. We do not round until the very last step. All right, so I have 2 side lengths here. I need to find another side length. What other side lengths can I find? HI, yeah, if I want to find HI, I can do that. Can I find GF? I'm gonna find GF, and I'm gonna find GF because there are fewer negatives. That's my strategy there. Okay, so now I want the distance between G and F. So again, I'm going to set up my giant square root, and I am going to set up my bubble squared and my other bubble squared. So I fill in the spaces here. All right, so to get started, I want to look at my x values and subtract them. So I have my 2 and my 8. I'm going to subtract them, 2 minus 8. And I'm going to subtract my y values now. So my y value is 1. Oh, wait a minute. 1 minus 1. Do I need to use the distance formula on a line like this? Oh, interesting. Let's see what happens. I'm working way too hard here. Let's see. So 2 minus 8 is negative 6. And negative 6 quantity squared is 36. Negative 6 times negative 6 is positive 36. And here we get 1 minus 1 is 0. Oh, so it's just the square root of 36. What is the square root of 36? Yeah, it's just 6. Hey, which I could have gotten just by 1, 2, 3, 4, 5, 6, counting blocks. Okay, who knew? This line is perfectly horizontal. The same is true about a perfectly vertical line. I don't have to use the distance formula on lines that are horizontal or vertical, okay? Because turns out we're going to get a 0, and it's just the length of the segment. We can just count it. If it's a slanty line like the first one we did here, you are going to have to use the distance formula, okay? So it turns out that this is 6. What is HI? 6 as well. Okay, so if I want the perimeter, then the perimeter is going to be radical 97 plus radical 97 plus 6 plus 6. And then I get to use my calculator, and I'm going to get a perfect answer. So in my calculator, I'm going to type in radical 97 plus radical 97 plus 12. And I get 31 point, if we round to the 10th place, what's that going to be? 7. To the 10th place, we look to the neighbor to the right. So we always go 1 to the right, and that 9 is going to tell me to keep the 6 or raise up the 6. And because it's a 9, we're going to increase the 6 to a 7, okay? Delta Math is very particular about rounding. So read carefully. Okay, there's the perimeter. All right, the area for a parallelogram turns out to be much easier. I guess I'm going to use this. The area for a parallelogram is basically the same as the area of a rectangle. It is base times height. Or length times width. It means the same thing, base times height. But what we want to understand about base times height for the area of a parallelogram is we have to know what the definition of a base is. It doesn't necessarily have to be the bottom, but the base and the height have to be at right angles to one another, all right? So here we have our base, and the height is the distance that is perpendicular to that, straight up and down. So here we see these two. This is called the base, and the height is right here. So you see how they're at right angles to each other, perpendicular to one another? Okay? That's how we find the area. So the area of this parallelogram, what's the length of our base? 6. And then we want the height here, and again, it's straight up and down. And so it is 1, 2, 3, 4, 5, 6, 7, 8, 9 units tall. So all we have to do is count. All right, so the area is 9 times 6, which is 54 units squared if we want. And so there's the area. I'm not sure how many questions are going to ask you for area, but that's it. Area of the parallelogram is just base times height. And again, drawing on that picture, I put it here for a reason. 6 times 9, base times height, okay? Questions on number 1? All right, let's look at letter B. Go ahead and we're going to plot these again. So -7, -8 is G. -7, -8. H is -1, -8. And I is -3, -2. Right there. What figure do we have here? Triangle, yeah. Okay, so once again, if we want to find the perimeter, we're going to have to find all 3 side lengths. Is there an easy side length that doesn't take a ton of work? What's the side length that doesn't take a ton of work? The base, yeah. The base right here. This base is easy to count because it's just horizontal. And so we can count 1, 2, 3, 4, 5, 6 boxes there. So it has a length of 6. But we have 2 slanty sides, so I need to figure out the length of the slanty side there. And I need to find the length of this slanty side, GI. So we have 2 distance formulas to do here. So I want the distance. I'm going to start between H and I. The distance between H and I. So again, I'm going to use my big giant square root here. Set up my bubbles, squared, and my other bubbles, squared. All right. We need to subtract our x values. So my x is are -3 and -1. So I'm going to do -3 minus a -1. And I need to then subtract my y values. So my y's, -2 and a -8. -2 minus a -8. All right, a little bit of cleanup. -3, what happens to minus a negative? Positive. So we have -3 plus 1 is?
4.
-2. And then if you square it, what do you get, Quentin? 4. There we go. All right. So we get +4 plus, here we have -2 minus a negative, so plus 8. -2 plus 8 is 6. Squared is 36. All right. And so that is 4 plus 36 under a radical is square root of 40. And again, this is a lovely exact answer. The minute you put it into your calculator and it turns into a whole bunch of decimal point gobbledygook, it's no longer exact, okay? So I'm going to leave it nice and exact. I'm going to just write radical 40 right next to that line. So that's our pink line there. And is the yellow highlighted one the same or different? It's different. It is not the same. You can tell it's different because if you think about the slope, the pink slope goes over 2 and up 1, 2, 3, 4, 5, 6. So over 2, up 6. The yellow line goes over 1, 2, 3, 4, and up 6. It's going to be longer because it has farther to travel. Does that make sense to you? Okay. We're going to get really good at slope in this class too. All right, so same thing, I want to find the distance between G and I. And that's my yellow line there. All right, so once again, Clayton, set up your square root. Bubble squared plus bubble squared. All right, I need to subtract my x's between G and I. So I have a -3 and a -7. So -3 minus a -7. And subtract my y's. So -2 minus a -8. -2 minus a -8. All right, and I'm going to do some cleanup here. -3 plus 7 turns into 4, and 4 squared turns into 16. Great. -2 plus 8 turns into 6, and 6 squared becomes 36. Very good. And 16 plus 36 turns into 52. Right? 52? Yeah, okay. So radical 52 then on that yellow length. And so how do we find the perimeter? Add up all the sides. So radical 52 plus radical 40 plus 6. Very good. And now we go straight to our calculator. So radical 52 plus radical 40 plus 6. And we get approximately 19.5. The 5 is going to stay because its neighbor is less than 5. So the 5 stays. All right. How do you find the area of a triangle? So that'd be a rectangle, a whole rectangle. But I want the triangle, which is really just cuts that rectangle into 2 equal pieces. So the area of a triangle is 1/2 base times height. So if you take a triangle or a rectangle, we can find the area of that rectangle as base times height. A triangle, just right there it is, it just cuts it in half, all right? And so there's a half in front when we find the area of a triangle. It's 1/2 base times height. So once again here in my triangle, I have this lovely base of 6, and the height, again, has to be perpendicular, has to be straight up and down. And so we're going to go to the highest point here, which is right here to that apex. And how tall is that? 1, 2, 3, 4, 5, 6. It's also 6. And so those are our base and our height there. So it's going to be 1/2 the base of 6 times the height of 6. What is 1/2 6 times 6? 18. Yeah, 6 times 6 is 36. Half of 36 is 18 square units. Okay. Unit, whatever the unit happens to be. All right, questions on those? Do you need one more, or you think you're good? It's the same. It's another parallelogram. Are you good? Yeah? Okay. Awesome. Then you may go ahead and grab those Chromebooks and start the 1.4 Delta Math.